Good morning to you all. Today we can start with the module gaseous state. But before going to details, first we can recall the things that we studied earlier. We all are familiar with the term matter. We can say that anything that has mass and occupies space is called a matter. Now, the matter can be classified as solid, liquid, or gas on the basis of the form of existence. Now, all the three states are made up of atoms, molecules, or ions, but the behavior of these particles differ in the three phases. Now, look at this figure, okay? Now, this represents the solid state. Here, the molecules are tightly packed in a regular pattern. Now, this represents the liquid state, and here the molecules are close together with no regular arrangement. Now, this represents the gaseous state. Here, the molecules are far apart with no regular arrangement. Okay. Now, we can say that water is a good example in nature where these three states can be observed. Now, coming to the properties of gases. It has no fixed shape, then no fixed volume. Here, the molecules are far apart. The force of attraction between the gas molecules are least, freedom of movement maximum, it has a high kinetic energy, and also the diffusion rate is a maximum. Now gas laws. Laws that relate the pressure, volume and temperature of a gas are commonly called gas laws. Only the perfect or ideal gas obey the gas laws at all conditions of temperature and pressure, and so we can call these laws again as ideal gas laws. Real gases always deviate from these ideal gas laws. Ideal gas laws. Number 1, Boyle's law. When the temperature of a gas is constant, the pressure of the gas varies inversely with the volume. Now, this law can be expressed mathematically as pressure is equal to constant by volume, or PV is equal to constant. Hence, we can write like this: P1 V1 equal to P2 V2. Okay, where V1 is the volume at pressure P1 and V2 is the volume at pressure P2. Now look at the figure here. Assume that this process is occurring at a room temperature. In the first case, the pressure applying through this piston is high, and so the volume of the gas molecule inside is very low. Now in the second case here, the pressure applying to the gas molecules by the piston is low. So the volume of the gas molecule inside here is high. Okay. Second, Charles' law. Now, this law states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature when the pressure is held constant. We can write it mathematically as V is equal to a constant into T, or V by T is equal to a constant. If V1 is the volume at temperature T1 and V2 is the volume at temperature T2, then we can write it as V1 by T1 equals V2 by T2. Okay. Now consider this figure explaining the Charles law. Now consider a beaker. The volume of the liquid inside this beaker is a 0.5 liter. Okay. Now here the pressure is kept constant and it is a 1 atmosphere. Now we are applying this is the temperature to this beaker. Okay. So what is happening is here the volume this is the increases as the temperature is increasing, but the pressure remains constant.